Hello everyone. In today's class, we will learn the third case of Doppler effect. What is that third case? Third case is when source and observer both are in motion. What is that third case? When source and observer both are moving. That is, I am writing here moving source and moving observer. What is that? Moving source and moving observer. In last two cases, we have learned that out of that two, one was at stationary. But in this case, both are in motion. That is, source is also moving and observer is also moving. Let's draw one diagram, small diagram. Suppose now this is the source which emits sound waves. And here is observer. He is also moving. So this is suppose P naught, either it can move here or this side also. And this source, it may be move this side or it may be moved this side because we are deriving the common formula. So let's see now what is the changes we are getting in this case. So first here, if I am taking a source, yes, then from this is what the wavelength emitted, and this is points where your observer is present, that is O. Now source emits sound wave of wavelength lambda, and here in this case lambda apparent is equal to P plus Ps divided by N naught. N naught is what? Initial frequency. And what is this lambda apparent? This is nothing but lambda apparent is apparent wavelength emitted by the source behind it. Okay. Apparent wavelength emitted by the source behind it. Now we want apparent frequency. Here, if I want N apparent, then what will be the N apparent here? P plus V naught divided by lambda apparent. This is all things are of relative velocity. Yes. Yesterday I discussed why V plus V naught and V plus Vs you are getting, because both are in opposite direction. So then there is a relative velocity. And here it is sound velocity, observer velocity, and Vs is what? Source velocity. You know this. V is what? Velocity of sound. V naught is what? Velocity of observer. And Vs is what? Velocity of source. So now this is apparent frequency. So therefore here N apparent is equal to P plus V naught divided by lambda apparent value we know. So this is V plus Ps divided by N naught. This N naught will go up, and hence we are getting N apparent is equal to n naught into p plus v naught divided by p plus. What is the formula? N apparent is equal to v plus v naught by v plus p. Okay. So when this is the case, and what is the common formula? Let's see ahead. Before that, first try to understand this. This formula we have to use when, and what are the sign conventions for it? I'm going to tell you ahead. So first of all, note down this. Pause the video, note down. Okay. So next one, what is the common formula for this? Common formula, n apparent is equal to p plus or minus v naught divided by p plus or minus vs into n naught. This is what your common formula. Now when to use which formula, that we will see. When we have to take plus, when we have to take minus. So for that I am giving you sign convention so that you can easily identify in which case which formula we have to use in case of both source and observer are in motion. So let's see what are the sign conventions. So first one, let me write heading. So here is sign convention. Number one, in the direction of propagation of wave, take negative. Okay. In the direction of propagation of wave, take negative. For both VO and VS, I am telling. VO and VS. For VO and VS. This is what velocity of observer and velocity of source. These sign conventions for V naught and VS I am telling. So in the direction of propagation of wave, in the direction of propagation of wave, take negative. Next one, second one, opposite to the direction of propagation of wave, opposite to the direction of propagation of wave, take positive. Okay. जैसे कि अभी एक एग्जांपल लेता हूं मैं so that you will understand. Suppose in example, one example, so that you should understand properly. Suppose now this is a source and this is direction of propagation of sound wave. This is direction of propagation. DPW. DPW means what? Direction of propagation of wave. Now assume that this source is moving in this direction, Vs, and here is observer, yes, and he is moving in this direction with velocity v naught or with speed v naught. Now what is our sign convention? Our common formula is what? N apparent is equal to v plus or minus v naught by v plus or minus vs into n naught. Now you see those which are in the direction of propagation you have to take minus. What is here in the direction of propagation? Vs. So therefore v, and this is opposite. Opposite means we have to take plus. So v plus v naught divided by v minus vs into n naught. This is what the formula we have to use in these type of cases. Understand? Is it clear? So you keep it in mind for V naught and Vs, what we have to do? If it is in the direction of propagation of wave, you take it as a negative, either it is V naught or Vs. And if it is in opposite direction of propagation of wave, then we have to take positive. Understood? Note down this. Pause the video. Yes. Oh. Okay, next. Now, let's make one table in which I am going to give you some important cases so that it will be easy for you to solve the problems. When you are going for solving problems, that time this table is very helpful for you. Let's make it. Okay, so I'm making this table. So you make three cases, we can say, three tables, not cases. So three columns we can make. Important cases. How and which formula when we have to use this table I am giving you with all possible cases. Okay, so let's see that all cases, possible cases. So you can make like this three columns particularly. In first column you write situation, or else you make first column as a serial number. Then here is situation. Then here apparent frequency. And here apparent wavelength. Okay, so this is what the cases and which column I have made, or table you can say. You can also make like this table. our table is ready. So serial number 1 situation is what you see. Suppose now I am taking velocity of sound, velocity of source, and velocity of observer. You can see here all are in same direction. This is V for velocity of sound, O means velocity of object, and S means source we can say. So this is having Vs, this is what? VO. Observer is moving here, source is moving here, all are in same direction. So here apparent frequency is what now? N apparent in this case is equal to N into P minus P naught divided by P minus Ps. Why? Because both are in same direction, or in the direction of propagation we can say. In the direction of propagation. That's why we are getting both are minus. Next, if I want lambda apparent, so lambda apparent is equal to V minus Vs by N naught, as N naught is our initial frequency. So this will become as lambda into V minus Vs divided by what your lambda apparent. Clear? Lambda naught you can say, lambda naught is initial wavelength, whatever. Second case, in second case, I am taking velocity of source this side, so I am writing only now velocity Vs, and I am taking V naught this side, that is opposite in direction, and V I am keeping same like this. Okay, V naught and Vs. What? Yes, and this is what? V naught. Now here you see which one is in the direction we have to take minus, which one is opposite we have to take plus. So here you are getting N apparent is equal to N naught. Who is in the direction? Ps. If it is in the direction minus, who is opposite? That will be plus. So V plus P naught by P minus Ps. This is what your apparent. And here lambda apparent, I am not writing any formula, direct one. P minus Ps by P into lambda. Same formula you will get. Next, third case. In third case, what I am doing? This source velocity is this side, that is Ps is here, and P naught is moving here. That is both are in opposite direction. Both are in opposite direction. This is velocity of wave or velocity of sound we can say. So in this case, N apparent is equal to N naught into which one is in the direction? P naught. That's why that will become minus. Who is opposite? That will become plus. Plus. And in this case, lambda apparent is what? Lambda naught into P plus Ps divided by, okay, P plus Ps by, in this case you are getting plus. And last possible case is what? Both are this side, hai? So Ps is this side, even V naught also this side, and this is what? Velocity of. So in this case, N apparent is equal to n naught into, both are in opposite direction, so both are plus, है ना, p plus v naught by p plus vs dot apparent frequency. And here lambda apparent will remain same. That is what, lambda naught into p plus vs divided by, okay. So this is what the table which gives you some cases while solving the problems. You can use these sign conventions and these formulas. So this table is very, very important for solving the problem. Pause the video, note down carefully. Okay. So next, now this finished all possible cases in case of Doppler effect. So let's move ahead. Now Doppler effect in reflected sound. What is the next topic? Doppler effect in the reflected sound. Now, how it is? First, let's see here. Assume that there is a car. Okay. So this car is moving with the velocity Vc. Velocity of car is what? Vc. And now there is wall in between, or what you can say, in the path. So I am drawing one wall here. Assume that there is a wall, right? The wall in between the, okay. So there is a wall. The wall. Now this car will emit some sound of one particular frequency. So this is a wall. And when these sound waves are getting incident on this wall, what will happen? There will be reflection of sound. Yes or no? What will be there? reflected sound we can say. Now, what we will do, we will treat this wall as a stationary observer. Point number one is what? We will treat the wall as stationary observer. Why stationary observer? Because we have learned one case in that source is moving, observer is at rest. Like that thing only will happen here. So that's why I am assuming that this wall will treat it as a stationary observer. Now let N naught is what? Frequency of sound. N naught is what? Frequency of sound. Then if source is coming towards the observer, we know the case. So for, as I have treated this as a stationary observer and source is coming towards the observer, we know this formula. N apparent is equal to N naught into bracket P by P minus P. Yes, but Ps is what? Velocity of source. But here Vc is what? Velocity of source in this case. That's why I'm replacing Vs with this. We know this formula. Now, wall reflects this frequency. Yes or not? Because this is apparent frequency. Wall reflects this frequency and behaves like a stationary force, stationary source, and behaves like stationary source. Means what? See, wall reflects this frequency and behaves like stationary source means now from this wall also again some sound waves are getting transmitted. Understand? Because that waves are not passing further. These waves are getting reflected back from that wall, and that's why the wall will behave as a stationary source. And this frequency I am denoting as a stationary source of frequency N1. तो यहाँ पे जो N apparent है, I will change it for our convenience and I am making it as a N1. Okay, first frequency. So that you will understand better. And car driver behaves like car driver behaves like moving observer. Means how? Now for second case, one more time listen. This is little crucial. First car is emitting sound. Okay, that is N naught, original frequency. Now when that sound wave is getting incident on that wall, it behaves as a stationary observer, and when it reflects back, that is nothing but a stationary source which emits frequency N1, that is apparent frequency. And now again that reflected sound, who will hear? That driver, car driver. So the and car driver behaves like a moving observer. Now in this case, source is at rest, observer is coming towards the source. Then behaves like moving observer, moving with velocity Vc. है ना? Moving with velocity Vc. Then in this case what? Let us keep it as a N apparent is equal to what? N1 into P plus Vc divided by P. This is the case when source is at rest, observer is in motion and observer is coming towards the source. This case we know. Now this n1 value we know already, we have find out. So let's substitute the value. Then n apparent, that is the final frequency. This is n apparent is what? Frequency heard by car driver. Frequency heard by car driver, we can say. So n apparent is equal to n1. Therefore n apparent is equal to n1 value we have to substitute this n1 value here. N0 N0 into P by P minus Pc into this P plus Pc by V as it is. P plus Pc by V. Okay. So this V and this V will get cancelled, and therefore N apparent is equal to N naught into P plus Pc divided by P minus Pc. This is what the frequency heard by the car driver. What is this? Frequency heard by car driver. You can keep it in a box. Understood? So pause the video, note down this. Okay. So small note point. Note point. In this case, number of beats. Number of beats, that is delta n, is equal to n reflected minus n directed. Then it is equal to, formula is what? 2 Vc into n divided by P minus P. Is what? Number of beats in this case. Number of beats heard. Okay. This note point you can note down. Okay. So if you will subtract this, you will get this. Yes. So note down this. Pause the video. Try to understand. Some part if you did not understand, listen one more time. And still if you have doubt, call me. Okay. So let's stop here. Have a great day.